The U.S. Navy is no longer experimenting with unmanned vessels at the margins. In fiscal year 2026, the service has initiated an institution-wide shift toward integrating robotic and autonomous systems across the surface and subsurface fleet. The Navy's dedicated unmanned systems budget climbed to $5.3 billion, a year-over-year jump of roughly $2.2 billion, while the Pentagon allocates $13.4 billion across all services for unmanned combat systems. Three developments mark an inflection point: the stand-up of Unmanned Surface Vessel Divisions 31, 32, and 33 under USVRON 3 in San Diego, the acceptance of upgraded Seahawk and Sea Hunter medium displacement unmanned surface vessels, and the planned integration of a MUSV with the Theodore Roosevelt Carrier Strike Group later this year. Simultaneously, the Navy canceled the Modular Attack Surface Craft program and replaced it with a fast-track marketplace procurement model that aims to field production-ready MUSVs by fiscal year 2027. These actions signal a procurement strategy targeting 30 medium USVs and thousands of smaller platforms across the Indo-Pacific by 2030, under the CNO's Hedge strategy and the Replicator initiative now coordinated through the Defense Innovation Unit. Three key findings shape this audit. First, the Navy has crossed the threshold from experimentation to operational deployment. USVRON 3 now operates dozens of small USVs, while 4th and 5th fleets integrate sail drone platforms into daily maritime domain awareness missions. Second, the shift in acquisition philosophy is as significant as the technology itself, moving from long development, exquisite programs to commercial-derived, modular, off-the-shelf procurement that rewards speed and scalability. Third, the undersea dimension is accelerating. Boeing delivered the second Orca XLUUV in March 2026. The ROMULUS 910 USV reached its 30% build milestone with sea trials expected in the fourth quarter. And the Dragonfish UUV effort inherited from Replicator received congressional support for accelerated development. The angle of this audit, Ghost Fleet Goes Mainstream, is validated by converging evidence, while the critical question becomes whether the Navy can scale from prototypes to a sustainment-ready posture before peer competitors operationalize their own rapidly expanding unmanned fleets. The foundation for today's unmanned surface fleet was laid by the Pentagon's Strategic Capabilities Office Ghost Fleet Overlord program, which proved that large unmanned vessels can operate autonomously over transoceanic distances. The test platforms, Nomad and Ranger, completed autonomous transits from the Gulf Coast to the Pacific, with Nomad covering 4,421 nautical miles in autonomous mode for 98% of the voyage. Both vessels passed through the Panama Canal under manual control and then resumed autonomous operations, demonstrating a blend of human supervision and machine reliability. Remote command was executed from an ashore unmanned operations center in San Diego, proving that government-furnished C4ISR payloads can be integrated onto vendor-provided autonomy and hull systems. Built on commercially crewboat hulls, the Overlord vessels embodied the commercially derived, rapidly procurable design philosophy the Navy is now institutionalizing. The program is transitioning from SCO to Navy ownership, with additional prototype hulls under construction to accelerate fleet experimentation and cement the build a little, test a little, learn a lot laboratory that earned the fleet's trust. The most concrete sign of institutionalization is the Navy's standing organizational framework for unmanned surface operations. Naval Surface Vessel Squadron 3 at Naval Amphibious Base Coronado now commands 3 subordinate divisions, USV Divisions 31, 32, and 33, formally established on 22 January 2026 in a ceremony presided over by Vice Admiral Brendan McLean, commander of Naval Surface Force U.S. Pacific Fleet. McLean stressed that USVs extend reach, reduce risk to personnel, provide attack options, and enable persistent surveillance in high-threat areas at a fraction of the cost of manned platforms. The growth trajectory has been dramatic. The Navy's USV inventory has expanded from a handful of prototypes to dozens of operational small USVs within a year, and USVRON 7 was established in 2025 to complement USVRON 1 and 3. Captain Garrett Miller of Surface Development Group 1 has outlined plans to stand up USV squadrons in every numbered fleet, with major command groups on both coasts. Lieutenant commanders now compete for division command, and the career pathway for unmanned warfare is being codified. As the unit motto "Victory through Ferocity" suggests, the shift from cautious experimentation to warfighting posture is unmistakable. The threshold event of 2026 is the planned deployment of a medium unmanned surface vessel with the USS Theodore Roosevelt Carrier Strike Group. Vice Admiral McLean confirmed at West 2026 that a MUSV will sail as part of the strike group later this year, with the aim of establishing a rhythm of integrating unmanned platforms into every future CSG deployment. Preparation has been methodical. In April 2026, the oiler USNS Guadalupe conducted an astern replenishment at sea with the MUSV Seahawk during a capability demonstration off Southern California. Captain Miller emphasized that the vessel is refuel at sea capable and must keep pace with the strike group without becoming an anchor. Seahawk's sensor suite is described as incredible, and the platform will deliver extended maritime domain awareness to the carrier and its escorts. Still, Rear Admiral Doug Sass noted a design paradox. When a USV must sustain speeds above 35 miles per hour over vast distances for 30-day endurance at low cost, the requirements become violently opposed, pushing the craft toward frigate-like complexity. The Navy's answer is a tiered approach: larger enduring muscles for direct fleet integration and smaller attritable platforms for distributed sensing and swarming. Early 2026 saw a dramatic acquisition pivot that reveals both urgency and tension. The Navy had merged the separate large USV and medium USV programs into the Modular Attack Surface Craft program, designed around containerized payload capacity on small, medium, and large hulls. By March 2026, however, Rebecca Gassler, Portfolio Acquisition Executive for Robotic and Autonomous Systems, announced MASC's cancellation and its replacement with a new MUSV Marketplace procurement model. Gassler characterized MASC as an unnecessarily conservative prototyping effort, adding that industry's USV solutions were already far more mature than the Navy had assumed. Under the Marketplace, companies submit manufacturing readiness assessments and design proposals, and selected firms receive contracts for on-water evaluation covering perception, collision avoidance, and a long-endurance mission within the same fiscal year. Those that pass receive additional funding and can move directly to fixed-price production or leasing, with first production deliveries required by September 2027. The speed of the pivot provoked industry criticism over wasted investment, yet the underlying shift from bespoke prototypes to production-ready, commercially derived platforms aligns squarely with the CNO's Hedge strategy and the administration's Golden Fleet vision. America's largest military shipbuilder, HII, is now making a concerted push into scalable unmanned vessel production through the ROMULUS program. ROMULUS is a modular family of AI-enabled USVs powered by the Odyssey autonomous control system, which has accumulated thousands of operational hours over 35 platforms with US and allied forces. In April 2026, HII announced it would build 4 additional ROMULUS 151 vessels alongside one already under construction, while the larger ROMULUS 190 reached 30% completion with sea trials planned for the fourth quarter. The ROMULUS 190 is designed for sustained open ocean operations, boasting speeds above 25 knots, a minimum range of 2,500 nautical miles, and capacity for 4 40-foot ISO containers. What distinguishes the program is HII's deliberate integration of manufacturing innovation, supported by the High-Yield Production Robotics Initiative that applies industrial robotics and digital quality systems to unmanned platform manufacturing. The production model is engineered for serial, repeatable output, using a commercially derived hull form rather than one-off construction. A trilateral industrial partnership, Bro Brothers in Louisiana, Bayer Integrated Systems, and Australia-based Incat Crowther further mirrors the AUKUS model in the unmanned domain. The undersea domain is undergoing its own acceleration with the delivery of Boeing's second operational Orca extra-large unmanned underwater vehicle, XLUUV, 2 in March 2026. The 85-ton, 85-foot Orca carries a modular payload bay over 33 feet long with an 8-ton capacity and a 6,500 nautical mile range, operating from pierside without a dedicated support ship. Although the program has suffered significant delivery delays, the Navy is planning mine-laying as the Orca's initial operational mission, leveraging stealth and endurance. From the Replicator initiative, the Navy inherited the Dragonfish UUV program, and Congress added $80 million for accelerating large unmanned underwater vehicles, funding that is expected to flow to Dragonfish and related efforts. Concurrently, the Surface Force is refining the doctrinal distinction between remotely operated drones and true robotic and autonomous systems. In the new framework, RAS use onboard sensors, artificial intelligence, and machine learning to make decisions with a human on the loop, monitoring rather than constantly commanding, a distinction that matters for deployment patterns, tactical speed, and escalation risk. CNO Admiral Daryl Cottle has explicitly linked this to his Hedge strategy, noting that many missions such as choke point defense, ISR, and maritime domain awareness simply do not require a full carrier strike group. AUKUS Pillar 2, centered on autonomous systems, artificial intelligence, cyber, and electronic warfare, is generating tangible operational momentum through the Maritime Big Play exercise series. In the latest iteration off Australia's east coast in early 2026, over 200 defense personnel, scientists, and industry participants from Australia, the United Kingdom, and the United States tested roughly 30 next-generation capabilities in a live tactical environment. Australian systems featured prominently. Innova Aero's Owl B one-way attack munition struck a target at range, while Speartooth's large uncrewed underwater vehicles served as a testbed for novel payload configurations. The Royal Navy has identified 3 focal points for 2026: a shared command and control software baseline, a common autonomous baseline, and an AUKUS test and reference environment that simulates real-world operations. The ambition was crystallized by Captain Keith Taylor, the Royal Navy's senior responsible officer for Maritime Big Play, who described the effort as turbocharging robotic and autonomous systems. A particularly striking demonstration occurred during Exercise Talisman Sabre when an extra-large autonomous underwater vehicle, physically located in the United Kingdom, was remotely operated by personnel in Australia, proving the ability to assume command of partner assets across the globe. Japan has also been integrated into AUKUS autonomous exercises, with a secure communications pathway tested to remotely launch uncrewed aerial systems thousands of kilometers away for targeting and situational awareness. This fast iteration, low-barrier collaboration stands in sharp contrast to the industrial base challenges and long timelines of Pillar 1's nuclear submarine program. China is not standing still as the US accelerates its unmanned naval programs. In April 2026, the People's Liberation Army Navy's Type 076 amphibious assault ship, Sichuan, displacing over 40,000 tons and fitted with electromagnetic catapults, departed on its first cross-regional training mission in the South China Sea, likely paving the way for air wings that feature large unmanned combat aircraft, such as the stealthy GJ-11. On the undersea side, China has already fielded 5 extra-large underwater vehicles, comparable to the Orca, and is testing 2 even larger XLUUVs, exceeding 40 meters in length, while a previously unknown 64-meter rocket-powered surface vessel was spotted at a shipyard in early 2026. At Dimdex 2026, Norinco unveiled the Sharp Shark 10, a 12-meter USV displacing 10 tons with a 6-cell vertical launch system for loitering munitions and twin water jets enabling speeds over 40 knots, and it has been cleared for export. Meanwhile, the Laoyuan 1 high-powered laser system completed live-fire counter-drone testing in the Bohai Sea in May 2026 and has been approved for mass production. These developments underscore that the unmanned naval domain is a contested space where the US and its peer competitors are racing to achieve both scale and operational maturity. The Navy's shift towards unmanned systems is fundamentally about distributing sensing and lethality across a larger number of affordable platforms rather than simply replacing sailors with robots. USVs are becoming a mechanism for buying coverage and magazine depth without the full cost of a destroyer, favoring open architecture control systems and modular mission packages over bespoke one-off classes. By 2030, the Navy expects to field at least 30 medium USVs and thousands of smaller USVs in the Indo-Pacific. Yet the gap between that ambition and today's handful of operational prototypes is substantial. The logistics of sustaining hundreds of unmanned platforms at sea, refueling, remote maintenance, recovery cycles, will demand entirely new support concepts, of which the April 2026 Guadalupe Seahawk refueling test was only a first step. For AUKUS, Pillar 2's unmanned dimension may prove the most consequential component, as it bypasses the slow-moving industrial base constraints that define the nuclear submarine pathway, and already demonstrates tangible interoperability at pace. The Ghost fleet has indeed gone mainstream, with organizational structures, career tracks, procurement pathways, and doctrine being built around unmanned systems at a speed unthinkable 5 years ago. Whether the Navy can deliver 30 MUSVs by 2030 and thousands of smaller platforms without repeating the cost and schedule overruns that have plagued conventional shipbuilding remains the central test. The ROMULUS production model and the MUSV Marketplace suggest that some lessons have been absorbed, but the abrupt and expensive cancellation of MASC after only months shows how far institutional acquisition culture still has to travel.